Welcome everyone to this next video channel on Python recursive function. Now today we are going to discuss on again Fibonacci series, which we have already done in previous videos. Now first of all, you have already seen how we can solve the Fibonacci um, series using a loop. Okay, simply using a loop. But since we are doing recursive function, we have also seen the way of how we could do the same using a recursive function. Okay, now in there are two ways as I have showed you. Okay, one is to generate and one is just to print the Fibonacci in that particular place. Okay, now if I run this program, this code, okay, so if I run this, you will see the output will be in this. Let me just show it from the beginning. Okay, so you enter the term, let's say I get 10, so it will generate 10 Fibonacci series, 0 1 1 2 3 5 and another 5 Fibonacci series because you have entered 10. Now another one is when you run this code, which I've already showed you this code, so you don't even bother to even copy it. Okay, in the previous video I've already showed you. Now if you run this, you will see that it's giving you 3. Okay, now why so? Because we have sent 5 to the function. Okay, the argument is 5 and 5 gets copied here. So what this particular program is doing is that it's printing that particular series, okay, that particular character, the series, okay, that is the number that is on the fifth, that is 1 2 3 4 5. So on the fifth position, okay, on the fifth, you can see the fifth Fibonacci sequence series, okay. And if suppose you change your code and then you just give 6, then if you run this again, you're going to get 5 because on the 6th, okay, 6, you will see that there is 5 on the 6th place. So that these two both are for Fibonacci, but one generates a Fibonacci series and one just print the particular number on that particular position. You can say, okay, say the fifth Fibonacci series is going to print just the particular number, right? But both is recursively, meaning we are using recursion function. Okay, recursive function. Even here as well, we are using recursive function. Now why then I take this class as separate class? Because this is a different way of using a recursive function. You will see while we construct the code for Fibonacci series. Okay, usually you will see when we were doing those other recursive function, you would see that we always call a function, of course, like in this way, same way. All recursive function calls itself in this way, but you will see that it calls only once. Okay, power. So this is a program about finding the power, right? And there is other programs of binary search also, where we call, of recursively we call the function. Okay, we can call the function. So that also is just once. Okay, and then we also have some kind of series in this way where we call the function again recursively, but only once in this way. So there are many programs, and I have showed you how this is executed, okay, at the back, okay, using a stack. But what makes Fibonacci series is that in Fibonacci series we use this technique of calling the function twice, okay, by adding them. So you see here also it's calling its own, okay, it means it calls itself that same function, but also it's adding to again and calling the same function. So what happens inside the program, how you got, as you saw that just now when I run this it was printing 3, right? Because 3 is on the 5th position. So how this is done? Okay, we just look at the code. It's so simple. It's just a 6-line code, so you can see. Okay, it's very easy to even to remember. Okay, but how actually behind how this works? Okay, so this video class is basically for that, right? So to explain this, okay, in a very simplest term, I have made something like this. Okay, you know that we have a stack. We always use a stack in our recursive function. Okay, so every time we call a recursive function, the value that you need to add or you need to multiply, you need to do anything, gets stored in a stack, after which it comes out from the stack. But since we have another function here, okay, that we are calling also, okay, in the same line, so how this is interpreted at the back, right? So let's just see how this particular program was giving you 3 when you give 5, and it was giving you 5 when you're giving 6, because the sixth Fibonacci series, or the sixth Fibonacci series was 5, so it was giving you 5, so on and so forth. If you give some other character, you send some other character, it's going to give you the position, the character on that. Let's say, suppose if you give 7, then it's going to give the 8, because 8 will be on the 7th position. Okay, so it will give you 8. Now how is this done? Okay, what happens at the back? So to understand this, let's start from the beginning. Okay, I've made it very simple. I just call this function in this way. 5, I'm sending 5. Of course, this needs to be printed at the end so that you get the output. Okay, so I have to print it, right? Now, first of all, let's start. When you call, of course, this function will be executed only when you call it. Okay, so I have called a function and I'm sending 5. So first of all, n will be equal to 5. When it's equal to 5, then it check if that 5, which is n, is equal to 1 or not. No, it's not equal, so it's not going to enter here. Else if n is equal to 2, no, 5 is not equal to 2, so it's not going to enter here either. So it's going to go to the else part. And in the else part, you are calling the function again recursively. That is, you're calling this up. But when you were calling, there are 2. Okay, so when you call this, okay, I'll just copy this. Okay, so what happened is you are calling and you're sending something. Now what is that something? N minus 1. N minus 1 means what? 5 minus 1, which is 4, which means you're sending 4. And also you have this another recursive function here, and this is calling something, it's sending something else, n minus 2, which is 5 minus 2, isn't it? Because n is 5. Okay, so actually from here you're sending 3. Now what happens here? When the first one, this one, of course, will start running because you're calling it, so it goes straight to this line. Okay, but then this goes to the stack, like in this case. Okay, I've just written n minus 3, so you are sending 3, but then this not gone there. Actually it's just one stack, but I'm keeping it separate so that you don't get confused. Okay, because you know that the output will come out from the stack, so you cannot add this or something, so I'm just putting it separately. Right, now the second case, what happens now? This will go to your program, which means you will get 4 here. So in the second, n now will become what? 4. Okay, now when it becomes 4, again it comes to the else part, because it's not equal to 1 nor 2. Okay, so it comes again here, and then it's the same thing. It is calling the function again, and this time you see it's fib n minus 2 minus 1. N minus 1 this time would mean fib, I'll just copy it so that you get it. Okay, so it's just like you're saying 4 minus 1, which is 3. Okay, and again this one calling again. Okay, and n minus 2 would mean 4 minus 2, which is 2, right? So this will go to the program again, but this will get stored where? It will get stored, yeah, I'll just copy this. Okay, but you see it's fib 2, not 3, so it'll be 2, right? Then this fib 3 of course will come here, so n will be 3, and again it's not equal to 1 nor equal to 2, so it comes to else part again, same. So the third, in the third, n is equal to 3, n is equal to 3, and same thing, you are calling a function again, and this time it's fib minus 1 again. Okay, and this time it means 3 minus 1, which is 2. Okay, and same thing here, this means fib n minus 2, which means it is 3 minus 2, and 3 minus 2 is 1, fine. So which means here, if I just copy this, and this goes to kind of a stack, you can say. Okay, and of course this time is 1. Okay, it hasn't executed, okay, these, right? So what goes for execution is fib 2. Now you are sending 2. Now definitely it is equal to 2, and when it is equal to 2, it is returning 1, and this one comes to your stack here. Let me just write it 1. Hope you can see, right? So that's a 1 there, so it's returning 1, so it's done. Actually, when it returns, it is done. So that's when this fib 1 will come out. Okay, now fib 1 will come out, which means in this n, what will come? 1. And when 1 comes, okay, let's see, I'll just rub this. This has come out, so it has come out. So it's 1 with 1. So when it's equal to 1, it is going to return 0. And when it's returned, it comes here. Okay, and again, it is 0. Right? And then the next one comes out, fib 2. Now fib 2 gets copied here, and again it comes to n is equal to 2, and then it returns you 1. Okay, which means again this one comes here, fine. So this fib 2 also has come out. Then this last one comes out, fib 3. Now 3, again it will go to the else part, you see. So in the else part, again it means, let's say, fourth. Okay, so in the fourth time, again fib enters as n equals 3, you see, because this will come 3 and it comes here, right? So this will come out, done. And when it comes here again, it's the same thing, it's going to return this, right? And then fib n minus 1 would mean 3 minus 1, which is 2. Okay, and this would mean 3 minus 2, which is 1, right? Yes, but fib 2 will go here, and fib 1 again goes to the stack, right? Then this 2, which means here it gets copied, 2 comes here, and then it checks if it's equal to 2. Yes, it returns 1 again. So when it returns, remember, it comes here, and again you get 1 there, right? Now this is done. Now this will come out. The moment after it finishes, it returns, this will come out, and this will come out with 1 again, and wait just a minute. Yes, with 1. Okay, so it comes with 1, and then this time it's going to return what? 0, right? So this also comes out. So now when you're done, this is done, you don't have anything, no one is calling anything anymore. So remember, recursion always stop with the base case. Okay, so we don't have anything anymore, okay, to run this. Okay, everything is done, all the function call. So that's when this will come out. Now what will come out? Just to show you. Okay, here 0 will come. This 0 will come out. Add it with 1. Then again next is 1. Next is 0. Next is 1. And which is equal to 3. And that's how you got this. Okay, when you run this, okay, because just now I started with 5, so I'm sending 5. Okay, and that's why when you run this, okay, and then you are going to get 3. Why 3? Because this. Okay, I hope with this you have understood, okay, how it works, okay, how these kind of recursive function works. So with this I end my class. Thank you.